Hey, have you ever wondered what the early humans feed on before the existence of fire? In today's world, you don't hunt for food. You won't dig it out of the ground with a sharpened stick or wait behind a bush for a bigger, more dangerous animal to finish its meal first. You'll open a fridge or a bag or a delivery box, and the hardest part will be deciding what you're in the mood for. That ease is new, astonishingly new. For nearly 2 million years before you, something that would eventually become you had to solve the same problem every single day, with no fire, no cooking, and almost no advantages over the animals trying to eat it instead. So what did it eat? And how did it survive long enough to become your ancestor at all? Picture East Africa, more than 2 million years ago. Hot, dry, open grassland dotted with acacia trees. Your ancestors here stood roughly as tall as a 10-year-old child today. Their brains were about a third the size of yours. They had no claws worth mentioning, no real speed, and teeth better suited to grinding leaves than tearing flesh. They were not predators. Not yet. They were something closer to prey that had learned a few clever tricks. That vulnerability mattered every single day. This was a landscape patrolled by lions, leopards, and an extinct saber-toothed cat called Dinofelis, sometimes nicknamed the false saber-tooth. Packs of hyenas roamed too, with jaws strong enough to crush bone that a human tooth could never touch. Every meal had to be found out in the open, in daylight, while staying alert enough not to become someone else's meal instead. Foraging wasn't calm. It was a constant, quiet negotiation with danger. Mostly, they ate plants, fruit when the season allowed it, leaves, roots and tubers, pried from the ground and often too tough or bitter to eat without serious effort, nuts cracked open between two rocks. This is the unglamorous truth behind most of your family tree, hour after hour of chewing, just to extract enough calories to stay alive. But the full picture is stranger than early humans ate plants. In the early 2000s, a researcher named Matt Sponheimer began studying something almost invisible, the chemical signature locked inside fossilized tooth enamel. Every plant leaves a slightly different carbon trace behind, depending on how it turns sunlight into energy. When Sponheimer's team tested the teeth of early hominins like Australopithecus and its relative Paranthropus, the results didn't match the gentle fruit and leaf diet everyone assumed. These creatures were eating far more coarse grasses and sedges than expected, or animals that had eaten those grasses first. The menu was tougher, weirder, and far less picky than the storybook version. Underground food may have mattered even more than it first appears. The primatologist Richard Wrangham, working with Nancy Conklin-Britton, proposed that tubers and other underground storage organs served as a crucial fallback food, something to dig up whenever fruit disappeared during the dry season. Unlike fruit, tubers don't rot on a branch or vanish with the rains. They sit underground, waiting, sometimes for months. A creature that knew where to dig never truly ran out of options. Then, around 2.6 million years ago, something shifted for good. Somewhere in your ancestral line, someone struck one rock against another and produced a sharp stone flake. It sounds small. It wasn't. That single flake could slice through hide that fingers and teeth alone could never manage. Archaeologists call these Oldwin tools, named for the site in Tanzania, where they were first found in large numbers. And with them, an entirely new food source opened up. Meat. Not hunted. Not at first. Scavenged. A paleoanthropologist named Robert Blumenschein spent years examining cut marks on ancient animal bones, trying to answer an uncomfortable question. Were your ancestors killing these animals themselves, or arriving after someone else already had? His research pointed towards something almost humbling. Early humans likely trailed lions from a careful distance, watching a kill unfold, waiting for the big cats to eat their fill, then rushing in before hyenas showed up to finish the job. Not an apex predator. More like a scavenger perfectly timing its arrival. Why take that risk? Because of what got left behind. Bone marrow. Brain tissue, sealed safely inside a skull. A lion's jaw is built for killing, not for cracking a long bone lengthwise, but a sharp stone flake can do exactly that. So your ancestors reached food the actual hunters couldn't touch. Dense, fatty, calorie-rich meals hidden in plain sight, inside bones the predators had already given up on and walked away from. Even hyenas, with jaws powerful enough to splinter a femur, tend to leave some marrow-rich bones behind more often than you'd expect, especially when they're rushed by competition at a carcass. That left a narrow opening. A short window between one set of teeth finishing and another arriving, just long enough for a small, clever animal with a rock in its hand to sneak in, smash a bone open, and disappear again. And they didn't always eat it alone either. A Berkeley archaeologist named Glyn Isaac studied sites in East Africa where broken animal bones and stone tools showed up clustered together in dense patches, again and again. His theory was that these were early gathering points, places where food got carried back and shared among a group, rather than eaten alone on the spot. That idea has been debated and refined since Isaac first proposed it, but the underlying pattern still holds up in the fossil record. Sharing food, not just finding it, may have been part of the survival strategy from a very early point in your family's story. This is where the story turns genuinely strange. Two researchers, Leslie Aiello and Peter Wheeler, proposed something in the 1990s that reshaped how scientists understand your own body. They called it the expensive tissue hypothesis. Here's the plain version. Your gut is expensive to run. Digesting large amounts of tough, fibrous plant matter takes a long digestive tract that burns constant energy. Your brain is also expensive. It's a small organ that eats up a huge share of your daily calories, just idling in your skull. Almost no animal can afford to max out both systems at once. So what changed? As the diet shifted toward richer, easier to digest food, like marrow and organ meat, the gut no longer needed to be so large. Every calorie freed up by a smaller gut could be spent somewhere else instead, on a bigger brain. This did not require fire. It did not require cooking. It required your ancestors getting better at finding and fighting for calorie-dense scraps using nothing but sharp stone and good timing. The brain reading this sentence right now may exist because a small, outmatched creature got very good at cracking open bones that lions had left behind. The numbers make the pattern hard to ignore. An early Australopithecus brain measured somewhere around 450 cubic centimeters, not far off from a chimpanzee's. Early Homo, the scavengers with stone flakes, show brains closer to 650 or 700 cubic centimeters. By the time Homo erectus was walking across Africa and Asia, brain size had climbed toward 900, even 1,000 cubic centimeters. That growth tracks almost perfectly alongside the shift toward richer, harder-won foods like marrow and organ meat. Bigger brain, smaller gut, better diet. All three moved together. Coincidence? Most paleoanthropologists don't think so. One more piece of evidence is worth sitting with. A researcher named Peter Unger spent years studying something almost too small to see with the naked eye, microscopic scratches and pits on fossilized teeth. Under a powerful microscope, hard foods leave different marks than soft, tough foods, and the pattern becomes a kind of diary written directly into the enamel. This is called dental microwear analysis. Unger's research showed that early hominin diets were not uniform at all. Some species leaned hard into nuts and hard seeds. Others show were closer to tough, fibrous greens. There was no single ancestral diet, no one correct way to eat. There was flexibility. And maybe that's the real twist in this story. You've probably pictured early humans as hunters or fire wielders, steadily climbing some ladder toward civilization. But before any of that, the trait that mattered most wasn't strength or speed, or even raw intelligence in the way you'd usually define it. It was adaptability. Tubers when there was no meat. Marrow when a lion happened to leave some behind. Nuts when the rains failed and the fruit trees stayed bare. Your ancestors weren't the fiercest animal on the savannah. They were the least picky. That trait never went away. It's still running quietly in the background every time you open your fridge. Think about the last time you were genuinely hungry and craved something fatty or salty or rich instead of a plain plate of vegetables. That craving isn't some personal flaw or a failure of willpower you're supposed to feel guilty about. It's an old signal shaped across nearly 2 million years by ancestors who could never predict where the next meal was coming from. A brain built on scavenged marrow and hard-won tubers has no idea that you live 5 minutes from a grocery store. As far as that ancient wiring is concerned, every rich, calorie-dense meal might be the last one for a while, so it's worth wanting badly. Even the shape of your day is a kind of echo. 3 fixed meals at roughly the same hours is a fairly modern habit, tied to clocks and schedules and school bells, not to biology. Your ancestors ate when food appeared and went without when it didn't. A big, fatty windfall, like a scavenged carcass, might mean eating well past comfortable, simply because nobody knew when the next one would turn up. That may be exactly why stopping after one plate can still feel, on some primal level, like leaving something on the table. And the fact that you still, more often than not, prefer to eat with other people? That instinct is old too. Long before dinner tables, long before fire, your ancestors may have carried food back to share it, not just to eat it alone in the grass. Every family dinner, every shared takeout order, every holiday table crowded with people passing dishes around, might be a very distant echo of a hominin dragging a leg bone back to camp instead of eating alone where it fell. You are not weak for craving what you crave, or for wanting company while you eat it. You are ancient. Fire, when it finally arrived, changed everything about how food got processed, how much energy it delivered, and how much time it freed up that used to be spent chewing for hours. That's a different story, one that unlocked an entirely new chapter. But none of it makes sense without what came first. Long before a single flame was tamed on purpose, your ancestors had already learned to shrink their gut, grow their brain, and survive on nothing but sharp stone, sharper timing, and a stubborn refusal to be picky eaters. So tonight, when you eat without a second thought, remember what that ease is actually standing on. It isn't effortless because food became simple. It's effortless because 2 million years ago, something small, slow, and outmatched refused to stop trying and figured out how to survive anyway.